finish the weekend. So, like I said, it's going to be another live about the future of Swift. And we are once again going to be looking at the Swift evolution proposal for a new feature that will be included in Swift 5.6. So, quick reminder, Swift 5.6 has not been released yet. It's going to be the next version of Swift. However, its features are already being discussed on the Swift forums and on the Swift evolution process. And when we take a look at Swift evolution proposal, we can see that for some features, it actually says that they are already implemented, and so they are basically ready to be released. So what we're going to do in this live is that we're going to take a look at the proposal for a feature called Introduce Existential Any. And I think it's going to be very interesting because from what I understand from the title, it's going to introduce a new keyword to the language. So if you haven't heard anything about this new feature, actually, you and I, we are at the same level of information because I haven't read this proposal. We are going to discover it together. If you have any question about it, you can ask them in the chat. So if you are following on Twitter, there is no chat, but you can follow the live on YouTube, and on YouTube you can ask questions. If you still have questions and you're on Twitter, you can just ask them by replying to the tweet, and I will try to reply to you, but only after the live has ended. Okay, so let's start scrolling and let's start seeing what this new Swift feature is all about. Okay, let's begin by the introduction. So existential types in Swift have an extremely lightweight spelling. A plain protocol name in type context means an existential type. So let me just explain what existential type means. If I'm correct, it means a type that exists in your app after you have built it, meaning it's something that can be checked at runtime. You know, like you can use the is operator or the as question mark operator. You can do a cast basically for this to be possible. Well, the type need to exist at runtime, and it's not the case of all types in Swift. Over the years, this has risen to the level of active harm by causing confusion, leading programmers down the wrong path that often requires them to rewrite code once they hit a fundamental limitation of value level abstraction. Let's open the link to see what it is. So, what's this link? It's a link to the thread to the Swift forums, improving the UI of generics. Okay, so this is something that you cannot write in Swift for now because collection, since it's a protocol with associated type, it doesn't have an existential. And okay, so if you had an existential, you could be able to write this kind of code. So this proposal makes the impact of existential types explicit in the language by annotating such types with any. Okay, I'm not 100% sure for now what this feature is about, but we're going to see. What are the motivations? So existential types in Swift have significant limitations and performance implications. Some of their limitations are missing language features, but many are fundamental to their type erasing semantics. For example, given a protocol with associated type requirement, so what we often call a generic protocol, even though the naming is not correct, it's protocol with associated type, the existential type cannot conform to the protocol itself without a manual conformance implementation. Because there is not an obvious concrete associated type that works for any value conforming to the protocol, as shown by the following example. So it's a little bit tough when you read that text to understand it. So let's take a look at the example. So we have a protocol P. It has an associated type A. Can I turn the switch form to dark mode? Yeah, it would be better, definitely. I'm not sure how to do it. Like my computer is set up to dark mode, but yeah, definitely. Okay, and then we have a function test that takes an A as its argument, okay? And then we have function generic, so a concrete P. It takes a concrete P and the value, so it's the associated type of P, okay? And then there is the second one. And so this one, that syntax is not valid in Swift for now, if I understand it correctly, because the question is, what would the value of P of A, B, because indeed, like we don't know, the compiler doesn't know in the general case what type A would be. There is no default value that makes sense. Okay, let's scroll down a little bit. So existential types are also significantly more expensive than using concrete types because they can store any value, whose type conforms to the protocol, and the type of value stored can change dynamically. Existential types require dynamic memory unless the value is small enough to fit within an inline free-word buffer. In addition to heap allocation and reference counting, code using existential types incurs pointer indirection and dynamic method dispatch that cannot be optimized away. So this is a little bit complicated, but basically what they're saying is that a lot of Swift performance and Swift good level of performance comes from the fact that Swift uh, does a lot of static typing, meaning that the compiler knows a lot of stuff at compile time, and the compiler can optimize things at compile time. Because if you take a look here, indeed there is a generic type, but the generic type, you need to provide a value at compile time. So when you build your code, the compiler knows what type concrete P is. The compiler knows what type concrete P dot A is. And so the compiler can optimize all of this. On the other hand, if you add an existential type like this, well, the compiler would not know what the types are at compile time. And so the compiler would have basically, well, to add some more code to make the checks and to call the right functions at runtime. And this has a cost both in memory, but also in performance. Despite these significant and often undesirable implications, existential types have a minimal spelling. Syntactically, the cost of using one is hidden, and the similar spelling to generic constraints has caused many programmers to confuse existential types with generics. In reality, the need for the dynamism they provided is relatively rare compared to the need for generics. But the language makes existential types too easy to reach for, especially by mistake. The cost of using existential types should not be hidden, and programmers should explicitly opt into this semantics. So what they're saying is that basically, if you can write code like this, like if this is a valid syntax, it will probably be, well, the go-to syntax that people use without even thinking about it, because it's just more intuitive than that syntax here. But since that second syntax has a significant cost associated with it, basically there should be some kind of keyword so that the developer really states that they understand that they are using something that has an additional cost over your, I don't want to say classic Swift code, but code that provides more information at build time. So what is the proposed solution? So the author is saying, I propose to make existential types syntactically explicit in the language using the any keyword. So this is a new keyword that would be introduced to Swift. This proposal introduces the new syntax in the Swift 5 language mode, and this syntax should be required for existential types under the Swift 6 language mode. So it's like it would be available in Swift 5 and then would become mandatory in Swift 6. In Swift 5, anywhere that an existential type can be used today, the any keyword can be used to explicitly denote an existential type. So let's take a look. So this is Swift 5 code. So we have two protocols, P and Q. Struct S implements both P and Q. Okay. So here indeed P is an existential type, and so in Swift 5 we could explicitly say that we are using an extension by saying it's any P. And the idea is that it makes it more obvious that while using P as a type for a variable has an extra cost in contrast to using a generic constraint. Okay. And here is the same thing, except that any now it applies to the combination of two protocols. Maybe it should be called like the, the union of two protocols. In Swift 5.6, existential types are required be explicitly spelled with any. Are required to be explicitly spelled with any, I guess. So in Swift 6, you don't have a choice whenever you're using an existential, so you need to write any to state that indeed you are aware that you are using an existential. Okay? Let's take a look at the detailed design now. So, grammar of explicit existential types. This proposal adds the following production rule to the grammar of types. So, it's the grammar of the Swift language. So, wherever we have a type, we can have an existential type. And an existential type, it's the keyword any, so the atom any, and then a type. So what's funny is that we could write any several times if we follow this syntax. Maybe the compiler will reject it, but it would be valid from the syntactic point of view. Okay, semantics of explicit existential types. So the semantics of any types are the same as existential types today. Explicit any can only be applied to protocols and protocol compositions or metatypes thereof. Okay? Any cannot be applied to nominal types, structural types, type parameters, and protocol metatypes. Once again, very, very technical words. Let's take a look at the example. So we have a struct S. So here it would be an error because actually using S as a type is something that is standard and it's the actual type. So it doesn't create an existential type for something for a protocol. So yeah, they deem it as an error because the keyword any is there to say there is an extra cost, and here there is no extra cost because there is actually no simpler way to type this variable. Okay? So here, using any of t when t is a generic constraint would also be an error, and it makes sense because the generic constraint you can see it as a placeholder for a type, but that type has to be provided at compile time. And here, so it would also be an error because this right here is a concrete type. So function types are concrete types. And so it would be an error because it would have no effect. Okay. Any and any object. Any is unnecessary for any with a capital A and any object unless part of protocol composition. Okay, so you cannot do any. Okay, that makes sense because like any and any object, it's already clear that you are definitely creating an existential that is going to rely a lot on the runtime because actually it's almost the on kind of like the only way I see to do something useful with an any is to use some kind of runtime introspection. So that makes sense. And the only time when you can use any with any object is if you compose any object with a protocol. And it makes sense to compose any object with protocol, like if you want to have something that conforms to P and also must be a class. Okay, so what's the rationale? So and any object are redundant. Any and any object are already special types in the language, and their existence isn't nearly as harmful as existential types for regular protocols because the typizing semantic is already explicit in the name. So basically, what I was saying. Okay, metatypes. So the existential metatype, i.e., p.type. So it's when you want to get the type of. It's when you want to manipulate the type. So for instance, when you do like something codable.self, that's the metatype. So p.type becomes any p.type. The protocol metatype, i.e., p.protocol becomes any p.type. The protocol metatype value p.self becomes any p.self. Okay, let's take a look at it. Okay, so if we want to take a meta type over an existential, we need to use any, which in a way makes sense. Okay, and then there are some rules, like it also applies to protocol composition. And here it's if I already have an any here, okay. Rational, the extension metatype is spelled any p.type because it's an extension type that is a generalization over metatypes. The protocol metatype is the singleton metatype of the extension type any p itself, which is naturally spelled any p.type. Okay, this is very, very technical. Let's see. Oh, damn it. Now we have logic and quantifiers. Under this model, the any keyword conceptually acts like an existential quantifier. So there exists t, formally, any p.type means there exists t that conforms to p such that I have t.type, I guess. I.e., for some concrete type t conforming to p, this is the metatype of that concrete type. Okay? Any p.type is formally okay. This is a little bit too complex for something for a live that I'm doing at the end of the weekend. Let's keep on moving. The distinction between any p.type and any p parenthesis type is syntactically very subtle. However, any p.type is rarely useful in practice, and it's helpful to explain why, given a generic context where a type parameter t is substituted with an existential type. T.type is the singleton protocol metatype. Once again, I'm not sure I understand this. I think basically if you're not working on the Swift language like regularly, this is a bit tough to comprehend. Metatypes for any and any object. So like their base types, any.type and any object.type remain valid extension metatypes. Writing any on these metatypes is unnecessary. So we saw that a little bit before. Yeah, like way too many any's. I totally agree with you. The protocol metatypes for any and any object are spelled any. I'm going to stop reading this. Let's see if it becomes a little bit more, not easier, but more actionable. Something that is a little bit closer to real life, real world code. Type aliases and associated types. Like plain protocol names, a type alias to a protocol P can be used as both a generic constraint and an existential type. Because any is explicitly an existential type, a type alias to any P can only be used as an existential type. It cannot be used as a generic conformance constraint, and any does not need to be written at the use site. Okay, so basically we can encapsulate any within a type alias and then use it anywhere where it's valid to use the keyword any. Okay. Once the any spelling is required under the Swift 6 language mode, a type alias to a plain protocol name is not a valid type witness for an associated type requirement. Existential type witnesses must be explicit in the type alias with any. So here I have a protocol P, some another protocol requirements with associated type A, then struct S1 that conforms to requirements, type alias A equal P. Okay, yes, if you want to use P here in a type alias, but you're using P as an extension in that case, you need to use any. Okay, like I can already see when this will become mandatory, there will be lots of people posting angry screenshots of compilation error on Twitter because it's going to confuse a lot of people, me included. Source compatibility. So enforcing that existential types that use any keyword will require a source change. You need to update your code. To ease the migration, I propose to start allowing existential types to be spelled with any with the Swift 5.6 compiler and require existential types to be spelled with any under the Swift 6 language mode. The old existential type syntax will continue to be supported under the Swift 5 language mode, and the transition to the new syntax is mechanical, so it can be performed automatically by a migrator. So that's kind of nice. Okay. There is another proposal, unlock extension for all protocols, enables more code to be written using extension types to minimize the amount of new code written that will become invalid in Swift 5.6. I propose requiring any immediately for protocols with self and associated type requirements. This introduces an inconsistency for protocols under Swift 5 language mode, but this inconsistency already exists today because you cannot use certain protocol as extension types at all. So that's true. Protocols with self, capital S, or an associated type, you cannot use them as extensions. And the syntax difference serves two purposes. It saves programmer time in the long run by preventing them from writing new code that will become invalid later. It communicates the existence of any and encourages programmers to start using it for other extension types before adopting Swift 5.6. Okay. Transitioning to any in Swift 6. So the new any syntax will be staged in over several major Swift releases. In the release where any is introduced, the compiler will not emit any warning for the lack of any on existential type. After any is introduced, warnings will be added to guide programmers towards the new syntax. Finally, these warnings can become errors or plain protocol names can be repurposed in Swift 6. So what's nice is that they're also like talking like how do you deploy a change like this to the language and try to ease it as much as possible so that like it doesn't break too many apps. Okay, no effect on ABI stability, no effect on API resilience. Alternative considered. This is always my favorite section because this is where you can see like other direction that the language could have gone into. So first alternative, rename any and any object. So instead of leaving any and any object in their existing spelling, an alternative is to spell these types as any value and any object. So using the new any keyword. So what does .self or .self with capital S do? So it's basically when you want to get the type, um, it's when you want to store the type either in a variable or pass it to a function. Think, for instance, when you want to decode something using decodable, you do like JSON decoder dot decode, you pass in the type. So for instance, I don't know, like array of movies dot self, that's that kind of thing. Basically, so .self, it lets you get what is called the meta type, and the meta type is the object that represents a type. And since it's an object, well, you can pass it to a function, you can store it in a variable, that kind of thing. So what they're saying in this alternative is that basically, yeah, they could have removed any and any object and instead use the any keyword to express the concept that, well, these two types mean. Though this is more consistent with the rest of the proposal, this change would have an even bigger source compatibility impact, given that any and any object aren't as harmful as other existential types. Changing the spelling isn't worth the churn. So this is interesting because basically what they're telling you is that if they had wanted to be 100% consistent across the language, they would have had to get rid of any and any object. But since any and any object are already widely used in apps and it doesn't like do a lot of harm to leave them, they chose to leave them because basically they don't want to force programmers to rewrite code that uses any and any object. So it's interesting because it shows you like when you have a language like Swift that is used well for big apps that basically bring a lot of money, you need to think also like in terms of kind of like an industrial vision. You know, you cannot change the language overnight, and sometimes maybe if something would make a lot of sense, it might be better not to go the extra mile because if you were to go that extra mile in modifying the language, maybe it could break a lot of things, and in the end, like it would do more damage than it would bring anything useful. But it's also that kind of thing that generates a lot of like legacy legacy code in a language. So it's interesting to see that they made that choice explicitly. The other alternative, so use any of P instead of any P. So why didn't they use a syntax like, yeah, having kind of like a generic container? So why introducing a new keyword to the language when a special type could have done the same thing? So a common suggestion is to spell extension types with angle brackets on any. So for instance, any of sequence. However, an important aspect of the proposed design is that any has a symmetry with some where both keywords can be applied to protocol constraints. This symmetry is important for helping programmers understand and remember the syntax and for future extensions of the sum and any syntax. Opaque types and extension types would both greatly benefit from being able to specify constraints on a specific type. This could naturally be done in angle brackets. So for instance, some sequence of int and any sequence of int, or some sequence and then element of sequence equal int, okay? Using the same sequence between opaque types, so type that use the keyword sum, and extension types, so type that use the any keyword, also makes it very easy to replace any with some, and it is indeed the case that many use of extension types today could be replaced with opaque types opaque types instead. Finally, the any of P syntax is misleading because it appears that any is a generic type, which is confusing to the mental model for two reasons. A generic type is something programmers can implement themselves. In reality, existential types are built-in language features that would be very difficult to replicate with regular Swift code. This syntax creates the misconception that the underlying concrete type is a generic argument to any that is preserved statically in the existential type. The P in any P looks like an implicit type parameter with a conformance requirement, but it's not. The underlying type conforming to P is erased at compile time. So it's interesting because like they see that there was this other possible syntax, but they say no, we want to use any, the keyword any, and not use the brackets because it's well, it's the same syntax than with the keyword sum. So it makes sense to have some like yeah, to keep things as seamless as possible, and also P is not really a generic argument in that case. It's more like it creates something that conforms to P, but uh, actually P is not present after the compilation has been done. Okay, future directions. So extending extension types. This proposal provides an obvious syntax for extending extension types in order to manually implement protocol conformances. So extension any equatable. Okay, so what does this do? I'm not sure I understand, like, because they're saying extension any equatable. Let me see. This protocol provides an obvious syntax for extending extension types in order to manually implement protocol conformances. I'm not sure I understand this correctly. Any equatable conforms to equatable. Yeah, not sure I understand this one. Repurposing the plain protocol name. In other places in the language, a plain protocol name is already sugar for a type parameter conforming to the protocol. Consider a normal protocol extension. So for instance, extension on collection. This extension is a form of universal quantification. It extends all types that conform to collection. This extension introduces a generic context with a type parameter self-conforming to collection, which means the above syntax is effectively sugar for a parameterized extension, so extension of self. Um, wait, you can do this? Like, you can write generic arguments like this when you do an extension? I wasn't aware of it, but okay, so it would extend. Maybe it's just like an example and not a real syntax, but I will check afterward. But yeah, when you're writing this, it's the same as saying that you're extending any type where the type conforms to collection. Okay, changing the syntax of extension types creates an opportunity to expand upon this sugar. If extension types are spelled explicitly with any, a plain protocol name could always mean sugar for a type parameter on the enclosing context with a conformance requirement to the protocol. For example, consider the declaration of append contents of from the standard library, so extension of array. We have a mutating func append contents of sequence where sequence.element equal self.element combined with a syntax for constraining associated types in angle brackets, such as, okay, we're talking about something else again, and it could look something like this. Okay, you could write it like this, but as far as I know, this is not valid in Swift. Yeah, it's a future direction. Like it's something that could be done in the future. So this sugar eliminates a lot of noise in cases where a type parameter is only referred to once in a generic signature, and it enforces a natural model of abstraction where programmers only need to name an entity when they need to refer to it multiple times. Okay? Speaking of sum, will opaque parameter in function parameter be in Swift 5.6? That's a good question. I've read that there is a proposal about it. I found it. I'm not sure if it will be in Swift 5.6. Maybe it's still in discussion, but I will check it out. Yes, it would make sense that they would introduce the two features, like maybe in the same release of the language. This way, like you can like understand everything together at the same time. So what were the revisions? What were the changes made to the proposal? So spell the existential. Okay, so that one I'm not going to go over it again. Preserve any through type aliases. Okay, allow any on any and any object. Okay, so it seems we have reached the end of this proposal. I'm just going to check here. So the proposal, yeah, unlocking extension for all protocols, it's accepted, but it's not yet implemented in Swift 5.6. So before I end this live, let me scroll up a little bit just to give you like a short answer of what this feature is, like the 1 minute or 2 minute recap. So let's see if we have an example of where the feature could be used. Like motivation, okay. Uh, okay, so I guess this is best thing we're going to find. So what is the purpose of this new any keyword? Basically, the purpose of this new any keyword is, well, to make it explicit whenever programmers are using an extension type that adds, we could say, well, some extra cost in memory and in performance. So for now, that syntax here is valid. However, when we are using the protocol P to statically type a variable, it has a cost because, well, the compiler doesn't know at compile time what is the actual type of the value stored inside the variable. And so basically the compiler has to, well, leave the room for some indirection to be executed at runtime. And also, since the compiler doesn't know what the actual type is, the compiler doesn't know what is the size of the actual type. And so most likely the compiler will have to allocate this variable in the heap, which is also a performance cost. So this is the situation as it is today. And the motivation for the addition of the any keyword is to say, well, whenever you are using an extension type in a situation where it adds a cost at runtime, you actually should be adding an extra keyword to state that you really understand that using P, the protocol P, as the type for a variable or for an argument as an extra cost. So basically, from what I understand, the keyword any, it doesn't really add any new feature, but it's more on the other hand, it restricts the use of existing feature, meaning that using extension types, well, if you want to use them, like starting in Swift 5.6, you will have to use the any keyword. And the reason is that since using an extension type as a cost, while having to write the any keyword will make it explicit in your Swift code that this choice indeed has a cost in terms of performance and in terms of memory. So that was the 1 or 2 minute recap of the new feature, given what I have understood when reading the proposal. Bear in mind that I could be wrong on some aspect. This proposal is a bit technical and it's the end of Sunday, so it's very possible that I might have like been not 100% accurate on some of the details. But I think for the general idea, I get what this new keyword is about. So this time, I think it's the end of this live. So thank you if you have followed it. So it was the first time where I was trying to do a live both on YouTube and Twitter. I'm really curious to see like if it has worked or if there has been like a big issue. And actually, I am speaking like to almost no one for the last 30 minutes. I will see. But anyway, if you have followed the live, thank you for following it. And well, I will see you sometime next week for the regular video and maybe some extra content. Have a good evening. Bye bye.